Hi, welcome to the Culture of Python. I'm Rob Richardson, and we're going to talk about what makes Python really interesting. Now, we can definitely talk about the syntax of Python and white space and for loops, and that is interesting, but that's not what we're going to talk about today. Today, we're going to focus on what makes Python's development experiences really cool. And in particular, we're going to look a lot at Jupyter today. Here's the part where I tell you I am definitely going to post the slides on my site tonight. But in this talk, there are no slides. Well, this is it. The code that we're going to see is online right now. Let's head off to robrich.org. We'll click on presentations, and here's the culture of Python. You can get straight to the GitHub repository for this content. While we're here on robrich.org, let's click on About Me, and we'll see some of the things that I've done recently. Both Microsoft and Docker have given me some awards. I'm a Redgate Community Ambassador. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. Now, I'd love to be with you here in Lansing in person, but unfortunately, I'm on an airplane right now, so past me is here presenting this talk. But as you find questions, you can find me on all the socials or hit me up by email, and let's definitely dig in. Some of the other things that I've done, I got to write a few books, including Pro Microservices in .NET 6. It's still applicable today. It's talking about architecture rather than a .NET implementation version. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. And if you'd like a .NET Rock, no, I'm just kidding. So let's dig in. We want to learn about Jupyter today. Let's start here with this fast API. I'm going to start it here, and let's take a look at this. I'm going to get some population, and let's look at 2007. And with most REST APIs here, we would expect to get JSON. But in this case, we're getting an image back. That's really cool. We can take a look at other images as well. So let's take a look at 2007 here, and we're going to get the GDP for various countries. That's interesting. Well, in this case, continents. Now, let's see how we can build up to this, building various Python things. Let's take a look at Jupyter. Jupyter is a really cool interactive mechanism for being able to do stuff. Now, it is a REPL, read, eval, print loop, but it does so in cells. We can also save these workbooks and pass them on to others. And so it's really a fun way to be able to interact with Python in a really elegant way. As we'll see, we can also do this in C#. So Jupyter, the name Jupyter comes from Julia, Python, and R, and that created Jupyter Notebooks. But we can do Jupyter Notebooks in all kinds of languages, not just Julia, Python, and R. If we use the Polyglot plugin into VS Code, then we can load lots of kernels. So for example, here's Dino kernel. We've got a C# kernel here. There's an F# kernel. There's a JavaScript kernel. There's the JavaScript kernel. And there's lots of different kernels that we can load, different runtimes, to be able to accomplish lots of different goals. Now, in this case, we're just going to use the Python kernel, and that's totally fine, but we will use the C# kernel briefly too. So how do I load Jupyter? Well, Anaconda is a great tool for low-code scenarios where you just click on the Jupyter thing and it just loads all the things that you need. Now, there are some licensing concerns with Anaconda now, which makes that a little bit problematic. That is definitely great for people who are less technical, but there's other tools as well. Jupyter Lab is a great way to be able to get started with Jupyter Notebooks and kind of gives you this interactive UI, which is interesting. Jupyter, just Jupyter, is a website that gets you the same mechanism for being able to run Jupyter Notebooks. We'll also see how we can run it inside VS Code. To be able to run the Jupyter package, it's just a PyPy package, not that unlike a NuGet package. So you install the Jupyter package and away you go. So let's do that. Let's flip out of here into here. And how do we get started? Well, the first step is to create a Python virtual environment. We'll say Python, pardon me, Python dash m venv. So we'll create a virtual environment .venv. In Python, things don't encapsulate into projects by default. Everything is global by default. So we do want to create this virtual environment. I've created it previously, so we can see this .venv folder. And so now let's activate it. So I would go into venv scripts activate. That's the PowerShell version. There's also a batch file version and a shell script version that I would use on Linux or Mac. I've already done that, and you can, I've already done that. And you can see that I'm in this Python environment right now. Next, let's run Jupyter Notebook. Now it's going to launch a browser automatically, which is great. But let's come back to this terminal and see what we did here. We can see that we launch it and we pass in this token automatically, this login token. So if you're using Jupyter behind, say, a reverse proxy like Nginx, or you want to host this publicly, then you'll still get that authentication mechanism, which is really cool. Now it's done this automatically, it's logged us in, and so now we're here inside this Jupyter folder. Now it just launched this folder inside Jupyter. We could launch any of these Jupyter notebooks, but let's create a new one instead. A new one, let's use the Python 3 kernel, and let's get a feel for how this Jupyter notebook works. Now the cool thing is we've got cells here where we can just type code. Let's say foo equals bar, and I'm going to hit Control Enter to run this. That runs that cell. I'll type B to build a new one. I could also push run and insert cell, but you know, it's kind of nice to use the shortcuts. Now I'll just say, what is the value of foo? Control Enter to run it, and we can see that we output bar. Now we can create cells that are code like this. Oh, so let's modify this. Let's say foo equals foo. I'll run this, and then I'll come back and rerun this cell, Control Enter, and now we can see that it keeps that value. It's going to keep those values going, and so we can just kind of iterate on things and hack on stuff, and once we get the values that we want, we now have the source code that gets us there. I'm going to create a new cell, and in this new cell, let's change this from code to markdown. So I'm going to hit M for markdown, and now this is the title, and here are instructions about this cell. Cool. Now with that markdown cell, let's build another one. We can say foo equals foo bar, and now we've been able to kind of describe what we're doing and then do it. Well, let's do this in a little, let's do a little bit more here. I'll build a new cell, and let's create a Fibonacci function. Paste that into place. Here's our Fibonacci function. Control Enter to run it. I can see that it is the 6th cell. I'll create a new one, and let's say Fibonacci. The hardest part of this presentation, learning how to spell Fibonacci. Let's go Fibonacci 10, and the answer is 55. I'm going to do that again. Fibonacci of 3, and we can see that that's 2. Cool. So we've been able to play in this notebook. Let's save this. Auto saved. And now if we flip this over, let's log out of this kernel and stop the command line here and flip over in this folder. Oh, it created untitled.ipynb. That's the extension here. IPYNB, that's a mouthful. Let's open up that same folder inside of VS Code. Now I've got this same folder here. Here's that untitled.ipynb. And because I have the Jupyter Notebook extension installed, I have all this content and I have the results that I ran. So this can be great if we're, hacking on something and we need to hand off these results to another team, or we want to ask somebody about it. let me just forward you this notebook and help me do this. Why is Fibonacci 10 this or Fibonacci 9 that? And they can pick up and do it. Now I just restarted the kernel here in VS Code, so it doesn't know what Fibonacci is. So let's rerun this cell. And now that we've run that, then we can come back here, rerun this one, and it'll run just fine. That's really cool. We can be able to update our content. We can test the things. And so let's take a look at other notebooks. Save. Now we just kind of built this Fibonacci notebook just as we did it. So here's that notebook where we can say run this and run that. But I want to be able to switch from Python to, let's say, .NET Interactive. So let's open up this other notebook, C#. Now here's some C# code. And so I'm going to switch to the .NET Interactive kernel, the runtime. And so let's build this Fibonacci builder here. Let's start up C#. Now that we've got C# running, let's run this C# stuff. And it's really cool. It's kind of LinkPad, but on steroids, but saving the results. So, you know, if you've ever had to worry about, well, I want to keep track of the things that I did so that I know the experiments I did and I know how this turned out, this is exactly that. That's perfect. Now, I've saved the results here. Let's clear all outputs, and that will set it back to 0. Now let's take a look at some scenarios that we might use Jupyter for and kind of feel out how might we use this in business environments. First up, I want to do some ETL. I want to move data from Postgres to SQL Server. Now the first thing is Docker Compose up. So I've got this Docker Compose file. It's going to spin up Postgres. It'll spin up SQL Server. And I'm loading some data into Postgres as we go. Here's a list of movies that will automatically get started inside this Docker Compose file. Perfect. So now that I've got Docker Compose spun up here, we can take a look at the data that we need to run. Back in VS Code, let's grab some stuff. Now we're going to use the Python library scikopug. I don't know how to pronounce that one, but let's go grab this library. Great library for interacting with Postgres. Let's connect to that database and select the data from the movies. Here's our results. Now it's going to show us this in Python arrays, and that is great. Let's load data from Postgres into a data frame. So let's go look at this gapminder.csv, and we'll inject that into our database, and then let's select that data back out. Now, in this case, we're using data frames here. What is a data frame? Let's take a look at what a data frame is. A data frame is a function that will transform our results. So maybe we're adding a column, or maybe we're removing rows, or we're doing each of the steps to be able to get from one set to a different set. And so the cool part about this is we're not creating another copy of all of our data every time. Rather, we're creating a pipeline that this flows through. We can think of this kind of like Hadoop functions. And they're not going to execute at all until we have something on this end that pulls the data all the way through. So once we have a sink that's running, then it will run all the data through each of the functions, and it's a really efficient way to do that. So we pulled this data into a new data frame, and we can take a look at that data frame, and here's the data that we've got. We pulled this here from Gapminder, and it lists countries and continents, the year, life expectancy, the population, GDP percentage, and GDP per capita rather. And so this data set is interesting. Let's see if we can learn more about it. So we grabbed that data out of the database, and we want to move this over to SQL Server. So now let's experiment with connecting to SQL Server. So I'm going to use the ODBC library for Python and connect to SQL Server. And let's create the movies database if it doesn't exist. And now that we've got a connection to SQL Server and to Python, then SQL Server and to Postgres rather, let's do our ETL. So let's first connect to MySQL. We'll load some Gapminder data into place. We'll select it back out. That will validate that we've connected correctly to SQL Server. And yep, we've got our Gapminder data here in SQL Server. Cool. We've been able to connect both to SQL Server and to Postgres. So now that we've validated that we can connect to each one, let's do some ETL, export, transform, and load. We'll connect to Postgres. Now we're going to use SQL Alchemy, which is a cool mechanism that kind of sits on top of all other SQL engines so that we get a single interface into both databases. So we'll connect to Postgres. We'll select the movies into this data frame, and then we'll connect to SQL Server, and we'll drop the movies table, we'll replace it, and then we'll read that data back out. So here's that data frame going into SQL Server. We'll read that data back out into a new data frame. Cool. Connect to Postgres, yank the data out, push it into SQL Server, and let's take a look at the data that we loaded, that data frame that we set right here. And we've got the movie data. Woohoo! This is a great way to be able to connect disparate data sources. And we created this interactive notebook so that we could kind of do some experiments and see if it works and move the data across. Maybe we need to adjust columns or data types, and we can definitely do that in a very interactive way with these data frames. I'm going to clear all the outputs. Let's save this one. Let's take a look at the next use case. This use case was ETL use case. Here, let's take a look at runbooks. Now we might need to do some application diagnoses. Maybe we've got some, our ops team is looking at various things, or we need to take a look at how this application is running. Maybe we're diagnosing a failed web server. Well, let's start by connecting to our Docker containers and see what containers are running. With this exclamation point in the front, we're no longer running Python, instead we're running shell scripts. So Docker container list, and we can see we've got our Postgres and SQL Server containers. If we had a web server, we might see our web server containers here as well. We could run kubectl commands or azd commands to be able to take a look at our application. So I have a theory that maybe the certificate is expired. Here's a get certificate function that will go grab the certificate and look at the statuses, make sure that that is as we expect, and definitely not error. So let's take a look at robrich.org and see if that works. So what does robrich.org look like? Well, it looks like that certificate is valid. Let's look at www.azgivecamp.org. Let's run this again, and we can see that, hey, that one is valid as well. Perfect. Well, let's take a look at the azgivecamp without the www. Does that website work as expected? Well, let's run it, and what we see is that we get an error. Oh, this is interesting. What we expected to get was a certificate for azgivecamp.org, but what we got was a certificate for dnsmadeeasy.com. I think we're getting closer to a clue about maybe what our website is doing and how we can get it back online. Maybe the application is having difficulty getting to the database. Let's go do a database query and see if that works. Well, yep, the database works just fine, so that's probably not the problem. So let's see if we can get to the home page. We'll go back to robrich.org here. We'll just go grab that, make sure the status code is as we expect. It's a 200. Here's the HTML from the home page. And that's interesting, but what does the home page look like? Is it up? Here we're going to switch into a different language. We're going to switch into HTML mode. We could just as easily switch into SQL mode or other languages. So we're going to flip into HTML mode, and let's see if we can load this iframe. Yep, there's the website. This works out great. Now, it was a really elegant way to be able to diagnose failures. We can create a suite of runbooks like this that give us various details about our application. And what we can do then is this runbook can be a great tool for having these playbooks as code. Now, the cool thing about these is we'll often have, say, a Word document of how you might diagnose something, and maybe the Word document gets out of date, or maybe we try to create README files, but this is an interactive run book that allows us to diagnose things. And the really cool thing is I noticed here that this URL wasn't working very well, so I can highlight this URL problem, save the workbook with this result, and then hand it off to my colleague and say, you know, this website isn't working. Can you take a look at the certificate? And they can maybe augment or add to the run book to be able to continue diagnosing this problem. Not only do we have the code, we also have the results. Now I'm going to clear all the outputs here, and let's take a look at the next scenario. Let's dig into some graphing things. We're going to take a look at 3 really cool Python libraries: NumPy, Pandas, and Matplotlib. As you start digging into data science in Python, you'll likely dig into these 3 libraries pretty deeply. First up, NumPy. NumPy is a great library for scientific math, as opposed to the built-in Python types that may not give you as much precision or as much capabilities. So I want to create an array of numbers between 0 and 20, step by 5. And so I have 0, 5, 10, 15, 20. You see the decimal point there? Yep, we've already gotten kind of into the scientific math thing. That's cool. Now I'm going to create an array of numbers from 0 to 20. And so with that, let me take a look at numbers before 3, numbers up until position 3, and position 14 and on, and I can take a look at those subsets of the arrays in a really elegant way. Let's take a look at a multi-dimensional array. You know, perhaps I'm doing vector math. We can see that here's that array, and I can ask for d.shape. How many dimensions do I have? And it gives me a 3 by 3. So here in NumPy, let's start to play with some data. We have this CSV, this grades CSV, that will give us people and their study hours and the grade that they got in their class. Let's see if we can find some correlations. So let's load this data in, and we'll just write it to a new file. If we take a look at this new file, we see that, well, we've got lots of math things going on, but it doesn't really understand non-math concepts. It just says, hey, that's not a number, that's not a number, that's not a number. Yeah. Okay, so maybe NumPy is not the best way to do data transformations like this. Next, let's take a look at Pandas. Now, Pandas does a really good job of adding data frames into these mathematical things. So let's import Pandas, and let's create this NumPy array and turn it into a Panda series. Now, in this data frame, we can see that it automatically created a primary key for us. That's wonderful. And as we print that series, it goes, oh, and by the way, it's a type of int32. Nice. Now I can create Panda series based on objects. So here's an A, B, and a C. So it'll turn those into rows in my data frame. That's excellent. And I can also do it on arrays of objects. So in this case, the array suggests rows and the object suggests columns. In the first object, I have A and B. In the second object, I have A, B, and C, but C is missing from the first object, so I get, hey, that's not a number. It did a great job of being able to infer the data types, except for it didn't have a data type in the first one, so it just said, I think it's going to be a float. So let's use Pandas to be able to read those grades and write the results to the new file. Here in new file, we can see that, hey, we've now got that primary key added. Excellent. We have the numbers here as we expect. We don't have not a number, but we do have blank spots because, well, yeah, in our original file, we had some blank spots for TED too. So as we look at this new file, we can also just dump this data frame to a table here, and we can take a look at those grades. Excellent. TED doesn't have any of the details. Adding to Pandas, let's also add Matplotlib. Matplotlib is a great graphing library built into Python that is really elegant to use. And so let's start to play with Matplotlib. we'll create a series from 0 to 5, step by 0.01. That'll just give us some stuff. And so let's just do some polynomial stuff. We'll do a linear, quadratic, cubic, so just multiplying numbers by themselves just to kind of play with the graph. Here's that graph. We were able to add a title or a legend, a title. We have some text in interesting ways. We have the series that we've given different colors, and we've actually saved this file as an image file on disk. Very nice. Now, maybe it's not the prettiest, but it does have some really cool options of how to be able to build up this graph. Excellent. So we were able to take a look at 3 different use cases with Python. We did ETL, we did runbooks, where we can diagnose various things. We did graphing in elegant ways. Let's see if we can put those together in this notebook, Graph from a Database. Now I'm going to start by importing pandas and SQL Alchemy. Let's also import matplotlib so that we can build some graphs. Let's do a selection into Postgres. We filled it with the Gapminder data previously, but just in case you run section 5 before you run section 2, let's go load up that database. Nice. Now that we've got that in place, let's select that data back out. Excellent. And now let's see if we can analyze that data in interesting ways. Let's look for the max year. Let's look for the earliest year. So we have a series from 1952 to 2007. Let's take a look at all of the years. 1952, 57, 62, 67. It looks like we're jumping by 5 years for each spot, and we have between 52 and 2007. Very nice. So let's go grab the last year. We'll subset the data to match this filter of that particular year. And so we could even say, well, I want 2002 here, and go grab the data only for 2002. But I'm going to grab latest because I defined that value up here. And so now we see only the data for 2007. Very nice. Well, with that data, let's see if we can plot it in interesting ways. Let's plot just the life expectancy, just the population, just the GDP. And so let's build those 3 graphs. Now we did save them here. Here's population across those continents. Here's life expectancy in those continents. And here's GDP across those continents. That's cool. We also then said show them. So it'll show us those 3 graphs here. GDP per capita in 2007 in Europe was quite high, but the majority of the world's population is in Asia. That's curious. So we can do lots of cool options, and I just kind of went hog wild with the various options here. Let's take a look at the aligning these 3. Now we don't have any legends on the y-axis here, but we can kind of compare these 3 data sets. Here's the United States. That's interesting. Let's look instead at United Kingdom. In the UK, GDP and life expectancy and population kind of correlated themselves in the same way as the United States. Let's look at Vietnam. Now in Vietnam, over the same period, we see GDP per capita was a whole lot lower. It's getting better. But because we don't have legends, we aren't comparing countries here. We're just comparing it to itself. Let's look at Zimbabwe. Well, if I run this for Zimbabwe, we see kind of some interesting things. Oh, GDP is all over the map, and life expectancy went down right about here. I wonder what happened in Zimbabwe in the early 2000s. Let's look at Iraq as well. Iraq has similar anomalies that are kind of interesting. We can see that population was pretty consistent, but life expectancy went up and down, and GDP went really far down in, say, the late 90s. I wonder what happened in Iraq in the late 90s. That's really curious to see. Let's do similar things here where we can start to add legends. Now I'm adding lots of legends all onto the same graph so that we can see different details. We've got the years as we did before, and we've got the various series, but now we have legends on each of these. Now, again, maybe not the most beautiful mechanism for showing this, but it does show us the capabilities of Matplotlib. We can get really detailed in these graphs, and we can dump them to disk in a really elegant way. So now how might we take a look at this? I'm going to set this one back to United States. And let's take a look at how we might then convert this Python notebook into a Python script. I'm going to right click here and I'm going to say import notebook to script. And now we have some of the features of notebooks, like being able to run cells, and that's pretty cool. We're going to start up a new kernel to connect to it. But we also have just Python code. So we can say, well, I just want to, make this into a Python app. Let's delete all of the cell data and let's read that data. And maybe I don't want these year mechanisms. Maybe I want to be able to prompt the user for a year. Maybe I might want to turn this into, say, a function call. My API, and I'll take in a year. That's interesting. So let's take that concept a little bit farther and open up number 6, which is not a Python notebook, but rather just a Python application. Now in this case, I'm also pulling in Fast API, a great API mechanism in Python. Let's connect to that Postgres database. We'll find our list of years, and then we'll spin up a whole bunch of APIs to allow us to do really interesting things here. Let's start this API. I'm going to come here and start up that API, and let's play with it a little bit. Now I did add Swagger to this API so that we can find these methods. Let's come back in here and let's take a look at that. Now here on the root, I just hard-coded the list of URLs in case you're running the sample later and want to just hit them. But let's take a look at, say, life expectancy. How's the life expectancy different in different continents in 2007? Now, unlike a traditional REST API where we would return JSON, in this case, we're returning an image. Now, we didn't save this image. We just streamed that image, that buffer, off to the browser. That's perfect. We dynamically created this image and streamed it down through this REST call. Very nice. We can do similar things. Let's take a look at the population across various things. 2007, and we can compare the population across continents. It looks like Asia has the majority of population here. Here's a circle pie chart. And let's take a look at the particular details for a country. We did this for United States previously, and we got to see the various graphs. We can see how population, GDP per capita, and life expectancy are decently correlated, but now we have the legends to be able to see them. By comparison, we can look at Zimbabwe, and we can see that graph with GDP per capita going all over the place. Now, the cool part about this is that all of these examples that we did here are available online right now here in this GitHub repository. You can get to it really easily by heading off to robrich.org/presentations. And though I wish I was here with you in person in Lansing, I'll definitely be online on all of the socials to be able to jump in. Head off to robrich.org, hit me up on any of the socials, or send me an email, and I would love to dig into this further. This has been so much fun getting to share with you the culture of Python, Jupyter, and the various scenarios that we can use. We can also use these scenarios in C#, by the way. Thanks for coming.